in computers, we always store things. You guys have probably heard of 1 byte. So 1 byte with a capital B. Oops. Okay. And that is actually equal to 8 bits. And what 8 bits are, it's like you have 8 things. And basically, it's electrical signals in the computer. It can either be on or off. On, off, off, on. And this is how information of any type is stored in a computer. So everything gets stored in these little blocks of ons and offs, and the order of the ons and offs and how many of them are on and off determines what the value is. And then you put a whole bunch of them together to get more complex stuff. So the way that this works, though, is this is actually binary. And in binary, well, let's say I wrote the number 123 in decimal, like the system we use for numbers. This actually means 3 ones, 2 tens, and 1 100. And the reason it's ones, tens, hundreds is because this is 10 to the 0 power. Anything to the 0 power is 1. This is 10 to the first power. And this is 10 to the second power. So all numbers are based on powers of 10, starting with the 0 power of 10. And if you have decimals, this is like, let's see, let's say a 4 there. That would actually be 10 to the negative 1, which is 1/10. So in the same way that we do this over here, we use that same system here, except I can use 10 digits here, but how many digits can I use here? If you only have on or off, how many different possibilities is that? 2, okay? So this would be the 2 to the 0 spot, 2 to the first spot, 2 to the second spot, 2 to the third spot, 2 to the fourth spot, 2 to the fifth spot, 2 to the sixth spot, 2 to the seventh spot. And if you look carefully, when you count from 0 to 7, you've actually counted 8 different things, okay? And so that means that this spot represents the number 1, 2, 4. This would be 8. And notice it's really just multiplying by 2 each time. So 1, 2, 4, 8. This would be 16, 32, 64, and 128. So you may recognize these numbers from like flash drives and memory on your devices. There's a reason why you always see like 32 gigabytes and 64 gigabytes and 16 gigabytes, because they're all powers of 2. So then to figure out what number this is, well, I have a 1, and I have an 8, and I have a 64. And together, that means my value that's stored here is 64 plus 8 is 72. So 73. So this is actually the number 73. Let's suppose that I wrote it in number form instead of in visual form. Let's suppose I wrote the number 01001001001. Okay, so this is, there's 8 digits here. It should usually be 8 digits that they write out. And then I'm going to look at these, and if I need to, just think out what these values are. So 1, 2, 4, 8, 16, 32, 64, and 128. So in this case, oh, did I write the same number? Oh, here, let's do a different number. 1, 1, 0, 1, 0, 0, 1, 1. There, that's different. Okay, so 1, 2, No 4, no 8. There is a 16. There is a 64. And there is a 128. And then if you add those together, 128 plus 64 is 192. Plus 16 is 118? No, 108. 110, 111. So is that 111? You guys can check my arithmetic there, but